do me a favor and pull out notes, maybe a blank set of notes, because I'm going to do two things. One is I'm going to start off and kind of give you step by step the steps along with a practice problem to help us with it. Sound good? So you are so neat. So we're not recording right now, are we? Oh, we are? Okay, so clearly what those of you who are reading this at home or whatever, this is not my handwriting. This is my handwriting. Sad panda. All right, so what we're going to start off with first is, where's my new page here? We're going to start off with multiplication and the steps that we follow with multiplication. Now, there is one code word. Now, I remember when you were doing the notes, you had a full page of instructions. There's one word for doing multiplication, and it is this, least. And that's in terms of how we deal with significant figures. Now, what I'm going to do here is, because I have the ability to just switch slides, I'm going to talk to you about the order of function first. In every single problem that we do, every one, we will always handle units first, then exponents, and then the significant figures. Does this ring a bell? You can still respond to me even though I'm miking. Okay? Now, what's kind of cool about this is these two things right here, when we're multiplying, what do we do with the exponents? We add the exponents. Do you realize that whatever we do for the exponents, we also do for the units? So when we're multiplying, if I would normally add the exponents, I'm also going to add the units. What about dividing? What do? We subtract exponents. So if we are subtracting the exponents, aren't we going to do the same thing for the units? And for adding and subtracting, what do we have to do with exponents? You're right. Make them the same. Make, and we're going to use the word M because it's cooler, the same. Make them the same. So keep this in the back of your mind, right? So we're going to go back to the original page that we had. And I'm actually going to put this in the corner just so we never forget. Our order of function is always units, exponents, and sig figs, abbreviated here. So now, the best way to do this is to practice a problem. So I'm going to give you like the top end problem you can do with multiplication. We're going to follow the steps through all the way through. So here we go. We're going to go, I'm making this as we go along, 433.791 times 10 to the 5th meters squared. And we're going to multiply that by 2.9 times 10 to the 3rd meters. In eager anticipation for me actually teaching this to you, have your calculators out if you could, and write down this number. And I'm going to follow the order. And I'll tell you the exact moment you can actually touch your calculator, and before that point, don't. Do you want to pause for a second? Okay, so we're coming back here. So order of function is simple. Units first. So since we're multiplying, I'll underline so that you can see this on the screen at home. We're multiplying. We're going to take our units and add them to each other. If I have meters squared, and isn't this essentially meters to the first? What's my new unit going to be? Meters cubed. Easy enough. We've taken care of the units. Now move on to the exponents. 10 to the 5th and 10 to the 3rd, we're adding them. We end up with 10 to the 8th. Now, this is the only point in time where you actually touch your calculator. I want someone to punch this number in and then give me all the number in its glory on your calculator. Someone have it for me? Go ahead. Can you read it out loud? 9939. Okay. Now, in the past, when we hadn't dealt with significant figures, we would be okay with this whole number. But we're not anymore. So now we've reached the point where we have to deal with our significant figures. So with multiplication, the key word here is, I'm going to underline it for your viewing pleasure, is least. So if we look over here and we look at the number, I'll use a different color because that makes it more fun. It disappeared. How many significant figures are there in this number? There's 6. How many significant figures are there in this number? 2. Now playing the game that's not hard to play at all, which is the least? 2. And the rule is quite simple. When you have the least number between 2, that's how many you're allowed to have in your answer. So here's what we do. We go down to our bottom number here, our answer, and we count over 2 spaces, 1, 2, and we draw our line of death. Our line of death means that everything to this side of the line, bye-bye, They're all gone. There is, however, a problem, and I want to point this out to you here. See how there's a decimal place right here? And it's to the right-hand side of our line of death? That means that if we're going to solve this problem out, if we leave the decimal place where it is, we're going to have to actually put zeros in as placeholders, aren't we? Here's what I suggest. And by suggest, I strongly suggest. Can't we shift this decimal place over 1, 2, 3 places to the left? And using the expression lefty largy, can't we make our exponent larger? Yeah. So if we do that, couldn't we then change this number? I'm going to do it down below, right underneath it. I'm going to erase all of this stuff right here. Wouldn't that give me the same exact number, but wouldn't it be 1.2579939? And how many places do we move the decimal over? 3. Lefty 3, largy 3. 10 to the 11th meters cubed. And now watch the beauty of this. The decimal's right here. So only these two numbers right here get to live. Everything to this side, not so much, right? We don't care about it. But we do care about one number. What number do we care about? We care about this 5, because this 5 gets to make a last request. The last request is either round up or stay the same. What does this guy say? Round up. So if it rounds up, then that gives me the number of 1.3. All these numbers are gone, and it becomes times 10 to the 11th meters cubed. I'm so overjoyed that I finally got to the end of my answer. I'm going to box it. And this is units, exponents, and Sig Figs done correctly. Pause. Here. So a little disclaimer here. This 5 is the only guy we care about. We're ugly that way. Whatever the number is next to the line of death, it gets to make the rounding call. Milo asked, what about this 7 rounding? Let's say this number had been a 4. What if this 7 rounds this 4 to a 5? Couldn't this 5 then round this 4? Nay. You allow 1 round up per problem. And I think I gave you this silly example where I had a number was like 0.444449, and the number over here was like a 3, and the line of death was right here. And so they went, this 9 rounds this to a 5, this 5 rounds this to a 5, this rounds this to a 5, this blah, 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 and now you can't do that. Okay. You guys ready? So this is kind of awkward because obviously we're trying to record along the way, but I'm trying to find ways to break up the content. So if you want to look on later and try and follow through again, you can do click on multiplication division and have it. Sound good? So, all right, we're ready here. So now let's go to division. And what is the key word for division again? What was the code word for multiplication? Wasn't it least? So guess what? The same thing here. It's least. And just so you have it, I'm going to always put this in the you don't have to be writing this down, but I'm always going to put my order of function, just so you know, it's units, then exponents, then Sig Figs. Now I'm going to go through this rather rapidly because all these problems are pretty much identical. So here's the problem. 9,000, that is a 9, although it's hard to read, 9,746.0039 times 10, oh, wait for this, to the negative 5 meters to the third. I'm going to divide that by 21.6 times 10 to the negative 7 meters. I've been deliberate here with writing it out. I want you guys to write it out here, please. Let's pause. Okay, so units first. Whenever we're dealing with multiplication, if we look back at the previous slide, didn't we say that whenever we're dealing with division, we subtract the units and the exponents? So coming back to this right here, we have units of meters cubed and meters. We have to subtract them, don't we? What's my new unit going to be? Meters squared. Now watch, and I don't know why it happens this way, but when we have negative exponents, our heads explode occasionally. Don't we have 10 to the negative 5 and 10 to the negative 7? And since we're dividing, are we going to subtract the exponents? Yeah. So we go 10 to the negative 5, subtract a negative 7. What is that the same as doing? Adding 7. So what's my new exponent going to be? 10 to the second. Brilliant. So now, and only now do you pick up your calculator and do you punch in what the numbers are. Can you guys do that for me really quick? So the number is what? Make sure you divide it. 4, 5, 1. One person. Now we're just getting kooky way over here, right? I mean, those numbers are never going to see the light of day in our final answer. So, but Oh, look at you guys. Look at you. So let's come back to this. We have the number here, but clearly we can't keep all these numbers in, right? So let's look at this number up top here. How many significant figures does this have? It has 8. How many here? And again, I'm going to underline this because I don't even want to insult your intelligence with asking which is less. Clearly we have 3 significant figures is less, right? So our answer is going to have 3 significant figures. Now, where does that fall? We start on the left-hand side and we count over 3 spaces. 1, 2, 3, and draw our line of death. Now, watch. Isn't the decimal on the line of death right now? So we're okay with leaving the number like this because we're not going to have to add zeros to get to the line of death, which is the problem we sometimes have. But my suggestion, which again is a strong suggestion, is when we're dealing with exponents, let's make it into good form right away. Can we do that? And what do? Don't we go lefty, largy, 2 places lefty? And wouldn't that make this into 10 to the 4th? So I'm going to rewrite it right below just so you can see it. It's going to become 4.512038843 times 10 to the 4th now meters squared. The line of death didn't change, did it? And the same rules apply. Everything to this side, bye-bye now. But we do pay special attention to the number that's right next to the line of death, which happens to be this fella. What does this fella say? Say the same. Right. In other words, this number is going to stay as is, and I'm going to write this down below here. It's going to become 4.51 times 10 to the 4th meters squared.